Section 8.2, there were two problems in this simulation, and we're looking at a system of three equations, and we're looking at the values of x, y, and z that will satisfy all of what we have here. And first things first, okay, so we have for the first equation, I have solely in terms of z itself. So I can go ahead and solve for z in this equation. So we have negative 5z is equal to negative 10. And in this case, we had that z is equal to 2. So we have z is equal to 2. And for what we have next, okay, so for the value of z at 2, this will be carried over to the next two equations. And for the next equation, okay, I can go ahead and solve for y, whereupon I have 5y minus 2z is equal to negative 9. So I can say I have 5y minus 2 times 2 is equal to negative 9. So I have 5y minus 4 equals negative 9. And if I add 4 to both ends, okay, so adding 4, I'm going to have 5y equal to negative 5. And we have with division by 5, the result comes out to negative 1. So I have z at 2, y at negative 1. And in solving for x, we have from the last equation, we have negative 3x plus 6y becomes 6 times negative 1. And plus 4 times z, so I have 4 times 2 is equal to 8. And upon combining, so we have negative 3x minus 6 plus 8 is equal to 8. You can probably go ahead and see that the 8's are going to cancel out. And so we have, in this particular case, we have negative 6 plus 8 is going to be negative 3x plus 2 is equal to 8. Take away 2, and we have negative 3x is equal to 6. And we have that x is equal to negative 2. All right, so we have, looking at what we have for the trio. Again, x is at negative 2. And we have y at negative 1. And again, we have z at 2. And checking out, and the result is correct. And for what we have in the case of the second problem, okay, so we have another system of equations, and this one is a bit of a twister because we don't have one variable isolated. And we have, for the system, so I have x plus 3y is equal to 1. And what I can do here is just to sort of tie in together, we have with x plus 3y equal to 1. So I'll go, what I can do here is just express what I have here in terms of x equals. It will not necessarily create a quicker pathway, but we'll say we have x is equal to 1 minus 3y. And for what we have in our other equation that involves x, we have 4x minus 3z. And what I can do here is that we have 4x minus 3z is equal to 13. And what I can do in the meantime is I can substitute for x, saying that I have 4 times the quantity of 1 minus 3y minus 3z is equal to 13. And we have with distribution, we have 4 minus 12y minus 3z is equal to 13. And okay, now if I take 4 away from both sides, so I have negative 12y minus 3z is equal to 9. Okay, and we have, so we have negative 12y minus 3z is equal to 9. And for equations that we have left over, so I've utilized the first and the last equations. Now we have negative 2y minus z is equal to 1. And if I take this equation along with this last equation I just formed, where we have solely in terms of y and z. So we have negative 12y minus 3z is equal to 9. And again, we have negative 2y minus z is equal to 1. And what I can do here is that I can either cancel out the y or the z. And what I'll do here, I think I'll go ahead and cancel out the z terms. So that which will cancel out negative 3z is going to be a positive 3z. And if I make the negative z into a positive 3z, I can just multiply this second equation by negative 3. And so we have, looking at what we have here, so we have negative 12y minus 3z is equal to 9. And multiplying the second equation by negative 3. So we're going to have 6y plus 3z is equal to negative 3. And if I add the equations together, we have negative 12y plus 6y is negative 6y. 9 plus negative 3 is going to be a positive 6. And with division by negative 6, we had that y comes out to minus 1. And I can plug y back into either of these equations, and we'll just go with this one. Okay, so we have negative 2y. So we have negative 2 times negative 1 minus z is equal to 1. Have negative 2 times negative 1 is 2 minus z is equal to 1. And if I take 2 away from both sides, so I have negative z is equal to negative 1. So we had that z is equal to 1. So y is at negative 1 and z is at 1. And going back to what we had for x, so we have x is equal to 1 minus 3y. So we have x equal to 1 minus 3 times y. And again, we have y at negative 1. Negative 3 times negative 1 is going to be a positive 3. So we have the x equal to 1 plus 3, which is going to be at 4. So we have, for this particular trio, we have that x is equal to 4. And we have that y is equal to negative 1. And we have that z is equal to positive 1. And if I look at taking what I have now, so I got 4, negative 1, and 1. So just filling in. So I got x at 4, y at negative 1, and we have z at positive 1, and checking the result, and the outcome is correct.